Hey, let's practice solving some literal equations. A literal equation is when an equation contains more than one variable, and you can solve that equation by getting the variable by itself, so isolating a specific variable. Let's take a look at our first problem here. They want us to solve for f. We also have the variable d. Essentially, your job is to just get f by itself. So we're going to treat 2d like its own constant term and subtract it and move it to the other side of the equation. So we have 9 minus 2d. We're almost there. It said solve for f, not negative 3f. So we need to move that negative 3 to the other side of the equation. So ask yourself, what's happening between the negative 3 and the f? They're being multiplied. So the opposite of that would be to divide by negative 3. Now that we have f alone, we need to see if we can simplify the 9 and negative 3, which we can. 9 divided by negative 3 is negative 3. But then we also need to do the same thing with negative 2 and negative 3. Negative 2 divided by negative 3 is positive 2 over 3, so those negatives cancel. And there's our final answer. We have solved a literal equation for f. Let's take a look at another one. Here we're solving for x, and I have an x and a y and an h and a u. I have a lot of different variables, but your focus just needs to be the x. Let's start by moving something away from the side where x is located. So x is on the left, and I'm going to subtract y on both sides. Now I have 4x minus 5h is equal to 9y plus u. I went ahead and subtracted the 10 minus 1 to give me the 9y. Now move the h. I'm going to add h to both sides, leaving me with 4x equals 9y plus u plus 5h. It's okay that there's not a like term, and now we can go straight into dividing everything by 4. Nothing in that numerator is divisible by 4, so I don't need to rewrite the entire fraction as multiple fractions. I can leave it simply as 9y plus u plus 5h all over 4. And that's solving a literal equation. I hope this helps, and be sure to check back later for more.